In this video, we will give you an overview of the Kelvin program, which is Integrated's two-dimensional or rotational symmetric thermal analysis software. We'll do this using a very simple two-dimensional model of a copper wire which is covered with rubber insulation and which contains a uniform volume heat source. Here we've opened the material table to show how the model has been assigned material properties. If we inquire on the inner circle, we see that's filled with copper, and the region between the two outer circles is filled with rubber insulation. Now, in addition, we have assigned boundary conditions, a convection boundary condition, to the outer circle, and we've assigned a volume heat source to the inner circle. Now, this is a solved model. We've solved this using the finite element method, and we can perform analysis on the solved model. For instance, we can calculate temperature contours on the surfaces of the copper and the rubber. We'll plot those now. Now you can see that inside the copper the temperature is uniform. The red color indicates the highest temperature, and as you move from the rubber towards the outer surface, the temperature decreases and it becomes blue at the outer surface, indicating that's the lowest temperature. To get a more qualitative feel for the temperature, we can plot a graph. And we'll plot a graph going on a line right through from one side of the rubber to the other. And you can see that inside the rubber the temperature has a steep gradient. Inside the copper the temperature is essentially constant. We can plot another graph just inside the copper. And now you can see that the temperature is again very constant, about 75 degrees, but there is a variation. It reaches the peak temperature right at the center of the copper wire. Another example of analysis that you can perform in Kelvin, we can plot an arrow plot of the Q field inside the copper and the rubber, and this is displayed as an arrow plot. The color coding again indicates the magnitude. Right at the center where you're enclosing very little heat, you have blue arrows, and those increase. The green arrows are a higher Q field, higher heat flux, and the maximum heat flux occurs right at the boundary, the interface between the copper and the rubber. Once you leave the copper and as you move through the rubber, the heat flux again decreases. So this should give you an idea of the kind of analysis you can perform in Kelvin, and in a later video clip we will build this model and show you how you perform the analysis.